let's see how we solve this city skyline problem. So do we have any submissions actually? Anybody got the brute force working? We have one?
Yeah, I do.
Oh, excellent, excellent, excellent. So we'll start with that. Right, so Edwards. Very good. All right, city skyline. All right. And I will see what's happening here. Right, so you have you even plotted something.
Yeah, I did.
Awesome.
With ChatGPT uploaded.
All right, of course, matplotlib, of course, right. So basically, again, so this is a pretty famous problem, right? And we have a brute force solution, right? Right, and max, right? Max that. Append zeros, you initialize, right? Zeros, right? First in range, right? And for building, you check buildings, right? Basically, and you find, okay, if buildings start, right, you check each building, basically, right? You go through buildings, and you return the max, right, at, basically, that's a list of items. The only thing, of course, here is the starting, well, yes, so you are assuming you start at 0, right? That's the assumption, right? Here. But okay, let's check this, right? Well, let's check. Right, we're not going to do the main, maybe we'll just do main here, right? I'll put this in a, so, very good, very good. And so let's select the kernel. Hopefully we can plot this. All right, and plot show, and where's my main? Okay, that's brute force main buildings plot building. Okay, so we'll need to run a main here, right? First, main. Yeah. Oops. No main guard. There's no point of main guard in a notebook, right? Let's see if this works in the notebook, right? Will it work? Or no, it's red, of course. Input. Okay, of course, there's no input city, and it's building. Okay, let's. And you use this. The one the provided set, right?
Yeah.
This one here, right?
Yes.
Okay, yeah, let's do that. So, all right, so input city buildings somewhere here.
Very.
Yeah, of course. Okay, yeah. I'll do this here. Source buildings text. Maybe we need to change later, right? So source. All right. Let's run it one more time. And all right, awesome. Looks awesome. Super. So we got our points. 1, 2, 3, 4, 5, 6. Well, there's one more here, right? It's missing this. Yeah, the 24 is missing this one. Awesome. All right. We will need to also check. Let's check the edge case. If you check or notice the second example, right? So what's the problem here? Or not the problem? You have two buildings, just like in Riga streets, right? We have two buildings next to each other from 0 to 2, 3 stories high, and from 2 to 5, right? Also 3 stories high. So answer is start at 0, 3 high, and at 5, also you drop down to 0, right? So so basically only 2 points, right? So let's see if your solution does work with this, right? So I'll convert this. Let's take a look if this actually converts correctly. All right, let's go back to our Skyline. Nice plotting. Very good. Again, of course, it helps. Of course, that this is not a relatively well-solved problem, right? For your midterm, I will change some things, so it's not completely trivial, right? So not so easy, right? But okay. Of course, this is nice if I see some visualization. Even if you have brute force and visualization, that won't get 10, but it will get a good grade, right? So I like to see visualization stuff. So let me add one more line. So buildings, let's do one more. Small buildings, small buildings, right? Text, right? So I need to do this again. So 2. The format changes, so 2, so 0, 2.3, right? Right, yeah, okay, something like that. Is there a comma? There's no comma, right? Small buildings, yeah. 2 to 9, 10, yeah, okay. Same format. All right, let's try the small buildings. All right, 2 buildings. All right, so let's see what our skyline looks like. So of course, what I want to do, of course, I'll change main to source, right? I'll do that. All right, and I'll do this, right? So this still works, right? Okay, still works, I hope. Yeah, it still works. So now, of course, I can run main on small building, right? AI is not smart enough to know that I have small buildings yet. It doesn't know it's. Oh, that now it knows. Yeah, it's smart enough. Okay, small buildings. Okay, let's see if this works. All right, what's wrong with this picture? Why doesn't work? List remove X not in list. Wonder what's. Was there some sort of global? So
yeah, no, if you go down a bit, go down. Here.
Okay, what's happening here? You're removing something here. Why? What was this?
I guess it only applies to the given first situation.
Yeah, why was it -1 0 removed? Is this like the last? You're removing the last item for some reason.
The first item. That was the first item.
Yeah. Remove, right, first occurrence of -1, right? You're removing the first item. And this was because it was in the buildings? No.
No. It was since I'm comparing it to the previous item.
Okay.
Well, you can try comment and add this line, I guess.
Let me uncomment this for now. See it works. And then of course we'll get, yeah, it still works. So now about this one. Okay, well we don't get the points, unfortunately. It's not plotting, but we see what's happening. All right, we see the actual plot. I would love to see the points actually, right? So these are the correct points, except we need one more here, right? On here we would like to see there's only 2 points. This point here, right, and point here, right? Basically, right? Critical points, right? Because that means, what did I say? Critical points, solution points, because that's where the change happens. You know, delta, basically, right? I mean, it's a way of encoding information, really, right? So we are encoding this information. Otherwise, of course, we have to provide it's the most compact way I could think of, right, of providing this information. I mean, you could have, information for each line, right, for each coordinate, right? But that's kind of silly, right? If you have a big, maybe 10 buildings, but they are really long and large, I don't know, factories or something, right? So, again, so 2 points. But okay, let's see, can we fix this code? I would like to see the point here. So you printed this 28 is correct, right? But why is not, we want also to see 24-0, right? Why is not 24-0 present, right? So what's the story with this? Let's see. Why is 24-0?
You can maybe try to, if you go to...
But and here, so this is...
Maybe in max, right, do +2.
Which one?
At the very top line.
Here?
Yeah.
+2?
+2,
Yeah.
maybe.
Yeah, let's try that one. Max building 1. Building 1 for building... right, because this is max right. This is how far we go. That's the coordinate. You think it's just so basically you think it's range basically, right? You're gonna check, right? All right, let's try that. Let's see. Yeah, it worked. Okay, awesome. And now it works perfectly. Awesome. All right. So let's look at the brute force solution again. So basically, again, hopefully you can see again. It's very. This is completely fine again as to get a good starting grade. So just realize, of course, if you have a lot of buildings, this is not going to be very efficient, right? So first of all, read lines, right? We get how many we have, and for line, right? We get our numbers, strip, right? Buildings append numbers, right? So what we're doing here, we're just setting up our data, right? So the big issue, of course, is again when reading this type of problems is which number is which actually, right? Because if you look here, right, it's hard to say which one is. So this is a left coordinate, this is the right coordinate, and that's a height, right? So especially second and third coordinate, you can make mixed up, and then of course your solution is completely wrong, even though you did good work. Right. Okay. So brute force points. Right. Yeah. So this is basically where you would stop technically. Right. This is pretty no. This
I
is
get all the max points and then strip like the middle one.
okay. I got you. Okay. So basically you're creating all the maximum points at each moment, right? And you strip the middle ones which are not needed, basically, because they stay the same. Okay, got you. All right. So let's look at brute force again. So max right, we find out. Let's add some comments. First, we find out how far to the right we need to go. Okay. Now we initialize, right? Initially, all the height is 0, right? We could have initialized zeros, but it's not, yeah, because we do it here, right? It's up, either way would work, right? Right. And since we skip initialization, we need to append zeros, right? And so then we check each building, right? And again, this is where Python shines, right? You have nice names, right? And you check what? So we check, right? So we check whether building is in the range, right? Right. And then we compare it, right? We have 0, right? We start, of course, height 0, right? Because potentially, we need to add zeros. Why? Because it is possible that no building is in a range, right? In the middle somewhere there's like a empty parking lot or something, right? So are you guys able to follow this solution? More or less? Well, Edward says, right? It's easiest for him, right? Because he did it, right? So both others, so again, so brute force, right? You just go through, right? So yeah, so the question of course is already how can we improve it again? So the issue is this. Since we are checking for each point, so this is, you have two loops, right? You have range, how many points you have to check, right? Integer points, and also how many buildings. So it's like x, well, you can say quadratic, but it is actually, depends on how many buildings and depends on how many points in between these buildings. So we can try to look at the two other approaches. But no, we probably won't get to two, since we have until 10:50. When do we stop? Yeah, 10:40 actually. Not much time to do the divide and conquer approach, right? But we could, right? So here, the plotting, that's nice. I love the plotting stuff. That's one of the things what I like about, of course, any AI systems is you can do all the dirty work, because it take me maybe half an hour to look up all the documentation for Matplotlib, which colors, all the settings, right? And now you have it. It's already on your on your plate given to you. All right. So these are good. So any other things? So I'm not going to look at the plotting. It's just basic, Matplotlib. But so solution, right? We check, right? If there is, so we go through. If max at 1 is more than max at 1, right? Okay. So yeah, we have to create a solution. Else, we basically. So if it changes. So let's look at this. So we go through. We have 2k. If it stays so basically, idea is this. If I correct. So idea, if not, no point. So if no change, we don't add it, right? Edwards, right? So in here, when we get solution, we don't add anything if there's no change, right?
Yeah.
It increases, right? So we have I max. So we have a new solution, right? I max, right? And then we see the previous, right? We make a stop there, basically, right? If there is a new max, means if max at y is less, so this means we are dropping, right? This means and we add a critical point, right? And before 1, right? So because there's a drop here, basically, right? Yeah. Okay, very good, very good. Max at I minus 1. All right. We append the value, right? Yes, and it means it drops, right? Means here means we are increasing, right? Right. Here we drop the height. Here we drop the height. Okay. All right. Oh yeah. So again, so it's two-part brute force, but again, so this is of course this is linear, right? The get solution is linear, but again, remember this part here. So this is the complexity of this solution. Right, n is number of buildings and m is distance to the right, basically, right? So, okay, so let's see, we have our buildings, right, and buildings here, right, and I'll probably make a function to get the point buildings, right? Buildings, append, where's my building? Oh, buildings here, okay, so what I'll do is, right, I will move this actually on a new function, right? I'll do a little refactoring, right? Get buildings source, exactly what I want to do, and yeah, I'll do this. We don't need, of course, read because that's default, right? It's open source because read is default, and of course I return the buildings, right? I would separate, so basically I would advise to the practical advice for your midterm to have a function ready to read text files, basically, right? So you don't waste 3 minutes or 5 minutes on reading text files, basically. Right? So there will be, almost certainly there will be some input in a text file, basically, right? Something like this, right? The exact format might not be, might change a little bit, but at least you should know how to read the file, right? A text file. So we return buildings, and now of course we get the buildings. We get building source. Let's try it again. It works. Okay. Buildings. Now the question is, do I have my buildings now? Mains my buildings again still works. Everything still works. Excellent. Right. So I can actually get the buildings and practice. Right. So what's the idea? So big idea. Divide and conquer solution. Right. Idea. And AI is so we have base case. So what's the base case? Right? If we have, what would be the base? Well, actually, we could have two cases, right? We have a zero input, right? Then we don't have anything, right? But okay, so what's the most basic base case? Like most.
Like the height at zero.
Well, yeah, that is, if you have no building. But so what would be the most, or what's our smallest unit we can look at?
One building?
Yeah, of course, one building, right? So we have one building, we have solution, right? Easy, right? We have our data, we have our points, right? So then, of course, the idea is divide and conquer, right? You split everything in single buildings, and then you just need some sort of way of merging them together, right? How to merge. You have to think, okay, so you have two solutions. How do you merge together, right? So you have these critical points from both solutions, right? And they are in sorted order, right? And you go through them and you compare, right? Which one is currently applicable, right? So we have this case, one building, then we have a solution, and we also have the conquer, right? So we have the base case, divide, right? Divide, conquer, where we compact, where we conquer, where we merge the solutions, right? Right. So all we really need to come up is an efficient merge algorithm or solution algorithm, right? The rest is pretty easy, but again, of course, I don't say easy, but of course, you have an hour and a half to solve it. It could take a while, right? So again, we have some. So now let's implement a divide and conquer approach, and of course we'll do a recursive, right? We'll see if this works, right? First, and to do halves and then merge results, right? All right. So of course, half, right, recursively, right. So let's see if this works actually out of the box. I don't think so, but we'll see. If length is building into one, right, building, right. Basically, we have one single building, and we know the answer, right? So this is our basic case. Now, the question is this actually going to work? We don't have the merge yet, right? That's the only problem. The divide and conquer is easy. We just need the merge, right? And we need to define the merge. And of course, I would do this, right? So how to merge, right? Let's see. Yes, so this is the only tricky part. Well, when you see here, you have two, left and right, right? And again, it's not immediately obvious what the heck is there left and right. It's basically, two solutions, basically, right? And you just need to somehow combine them, basically, right? And again, I would like to move the merge part on top, right? Let's see, result, right? So we check. It's kind of similar how we merge in a merge sort. There is some similarities with merge sort here. So some definite similarities between merge sort and this function, right? Hopefully, right? So you have 2 pointers. So these are so these are like pointers in merge sort, right? And we have a result, and we have any pointers left in our result, right? Indexes, right? Length left, length right, right? So we check, right? What's our current solution? It certainly looks good, but there could be an awful one error, right? Let's see. This is, and we get the maximum, right? And we append the new result, and we return the result. So now, well, let's take a look. So building 0, building 2, and building 1 is the height and 0. Let's see. This is okay. So we have buildings. 0 on 2. Okay. We have this looks okay. Yeah, and of course, initially, okay, makes sense. Okay, yeah. So if for single building, we return 2 points. One at the left with building height, and one at the right with 0, where the building ends, right? So this makes sense, right? So the base case makes sense completely, I think, right? And then again, so that's the beauty of the divide and conquer, that the solution is good, right? Except again this part here, right? So this is now we leave the difficult division, the beam that later, right? Of course, see below, right? So if you submit this to me, even if you don't have a good merge function, it's also give you some good credit, something like this, right? Again, assuming of course you get divide and conquer problem, right? So, all right, let's see if this works actually, right? We have what do we submit? We have buildings, right? So let's get buildings first. Let's get buildings. Let's get buildings. Yeah, all right. Let's print buildings. All right. Yeah. Okay. Looks okay. Just sanity check. All right. And now let's see if this is a recursive solution. How do we call this? Divide and conquer. All right. Let's get the solution. Right. Print. Name error. All right. Oh, I didn't run it. Okay. So the question is, so in this case, right, so generally, of course, I'm defining two functions, right? So in this case, it works, of course. Again, depending if you want to run it, of course, you'd have to, define it later. So now let's try this again. All right, unbound local error. So that's not very promising, right? So, H2. All right, so let's look at this. That's, of course, this hallucinated values. So we'll need to fix it, and that's, of course, harder than actually coming up with a solution yourself. So what heck is H2 and H1? H2, H1. Height 1, height 2. Right, I have a feeling. Here's the problem. Okay, you see the problem? It's possible, right, when we are doing a merge, right? So I would assume, right? So we need to put H1, H2, 0, right? Assuming. So one thing that's so obvious, easy way to fix, of course, let's set up H1, 0, H2 also 0, right? That's one way of fixing it, is that's gonna fix it, right? Let's see. Let's look at this, what's happening here. So we have length, right? We try to merge, right? If length left I 0 less than length I2, x equals left I 0, height 1 equals left I. Okay, that looks okay to me. Else if, right? Because what we're doing max, H1, H2. So this fix looks, this quick and dirty fix that I implemented looks okay. Is it gonna work? What do you think? Is it gonna work? Okay. All right, let's try this again. Okay, it works, but something's a little bit iffy here. I don't think it's quite correct solution. All right, let's see, 210, 315. This part here is a little bit iffy. You see the end is kind of off, right? Something is a little bit off. Let's look at our solution, and maybe I need to look at the problem. And it's the same data, right? So, 210, right, 315, and then you have a 7, 12, and I have 5, 12, and I have 7, 0, and I have 12, 0, which is fine, of course, right? Because you drop here, 15, 10, which is good, and you have 19, 8, 20, 0, which is not good, right? And you have 24, 0, which is good. So you have a couple, so there are actually some errors in the merge algorithm, right? So, okay, well, okay. Now let's do it on a simple solution, right? Let's do it, okay, let's try this. Let's try this. Let's try this on. Let's try this on small buildings, right? So small buildings. I'll do small buildings. Small buildings get to small buildings. Okay, print small buildings, right? On solution, small solution. Right, all right, okay, so in this case it works fine, so that's good news at least, right? But again, this is in some ways very good, but we have 2 minutes to finish, so the question is, okay, let's do this over again, right? Yeah, right, so these couple cases are a little bit worrisome, right? It's not, do we have the wrong data, or we don't have the buildings look okay to me, right? 3, 7, 15, 5, 12. Yeah, 5 buildings, right? 15, 10, right? This looks good. So question, why does this part here, right? It drops to 19, which is wrong, right? So there's some off by 1 error here. So there's off by 1 error somewhere here in the merge algorithm, right? So, yeah, this is so merge. So we have our pointers. This looks okay, right? We have our height. That looks good, right? So this is going to be hard. X. So this means if left, we need to advance the left side, which is okay. X is left I 0. That's good, right? If length of 0 equals 8 or h is not equal, result minus 1, 0. Okay, the previous result we append. Okay, we have 2 cases where we append either length is equal 0, means what this means, we have no, okay, we have no result. So this initial, so this is initial, so this is a check for initial. So we check for initial case on either head, or on either head is different. Okay, so that's the thing. So we'll need to print something here, how it works, right? Or debug it slowly. Offhand, right, it's like we should probably take a break. So to do find issue with merge. So to do appending here is fine, left or right, right? So we keep adding results basically, right? result. Oh, okay, yeah. So this is afterwards. Yeah. So this is basically idea is so these two checks, right? Then after merge, we need to add the remaining points from one of the lists, right? So the below two blocks only are similar, but only one of them will run, right? Whichever is list of the many. Okay, so this part is easy to understand. So the only issue, so the problem is here. So fix me, right? So fix me here. Fix me. There are some extra points being added, right? So let's see which ones are added. Right. So by the way, guys, yeah, you can take a break at 11:10, right? I mean, until we continue at 11:10 with our C++, right? Yep. The structures, right? But let's see if we can fix this. Of course, I have this maybe anybody else can fix this. Who has had more coffee than me? I need to finish this coffee. So, but we will see this again. Maybe less pressure to fix it. So H1, H2 looks okay, but there is probably something's big. Something here is added, which should not be added. So this part here, yeah, this one here is not needed. Do you have any idea?
No, I have something similar, but I stuck. So.
Okay, that's okay. But submit it anyways. Submit it anyway.